let's take a look at significant figures in calculations. So first of all, a significant figure basically just says when you're making a measurement, which number is important, which number is not important. So if you measure the distance of this coin, okay, so if we measure the distance of this coin, we say, okay, well, this is 2.5 centimeters. The 2, absolutely. The 0.5 is my guess. And once you make one guess, okay, that is your last significant figure. That is your uncertainty. I'm uncertain about that 0.5, but I know that it's not 0.1, let's say. So we're uncertain about it, but it's still significant. Anything beyond that, I have no idea. So I couldn't say 2.51 or 2.53. Like none of that makes sense because I can only be as measurement. I can only make one guess. So when we're doing calculations on measurements, okay, which we do a lot of, we can only be as accurate, as your least accurate measurement. So if I were traveling to work, and I've lived far away from work for a number of years, so I traveled 70 miles to work. I travel 70 miles to work, and then I get on my car and I travel another 30 feet to get to the classroom. Well, 300 feet to get to the classroom. How far did I travel? Was it 70 miles plus 300 feet? No, it was just simply 70 miles because the way I'm measuring the distance in the car is much less accurate than me measuring the number of feet walking to the. So you're always only as accurate as your least accurate measuring tool. Okay. So what is the radius of this coin? Well, we know that the diameter is 2.5, right? Diameter is all the way across. That's my diameter. And the radius is simply from the center to the edge. So half the diameter. So radius is equal to the diameter divided by 2. Well, we could just plug this into the calculator, and I encourage you to do it. 2.5 centimeters divided by 2 gives me an answer of 1.25 centimeters. Half of 2.5 is 1.25. There we are. We move on, right? Wrong. This is not correct. So before we continue, this number right here has 2 sig figs. Okay, 2 significant figures. So my measurement has 2 significant figures. When I divide by 2, this number right now has 3 sig figs. How is it possible that just dividing by 2, okay, that's not a measurement, but by dividing by 2, I now have 3 significant figures, right? So we run into a problem here. So what we end up doing is when we're doing multiplication, as it turns out, and we've got the rules below, I would underline that 2. I'm going to round to that 2 right there. And this is one of those special rules. It's that one special rule. 1 point, does the 2 go up or down? Well, because the 5 is next, the 2 rounds down because it is in fact even. So we keep it the same. Look back at the previous lecture if you don't remember this. But now my number has 2 sig figs. That's good. So my original measurement had 2 sig figs. After doing some math, I have 2 sig figs. We're happy with that. We're not allowed to add significant figures by just performing some math on it, okay? So there's 2 rules. This feels daunting, but I promise you it's not. So when you are adding and subtracting, we're always going to limit it to the fewest decimal places. The actual answer for this, it is fewest decimal places. That's what it tends to be. Really what it is the lowest place. And I will discuss that with you in just a moment, but here's an example. So I'm adding 22.3 and 52.02. So if we look at the place, the lowest place, the 22.3 is last. These are all significant, the digits here, because they are. This 3 is in the tenths place. And this 2 is in the hundredths place. So which one is higher? Okay, which one is less accurate or gives us a bigger measurement? It would be the tenth place. So we are rounding to tenth place or 1 decimal. Okay, so that means that I'm going to underline where I would round, and I want you to get used to doing this. Always underline where you would have rounded. So this becomes 74.3 because the 2 rounds up. Make sure we have the unit. 74.3 meters. Okay, so we always round up with that. Or I'm sorry, round down because we're rounding to that 3. So what about the next one? Where do I round? So write your answer for this one. Really quickly, and I will do one of these. Let's see here. So if I'm adding 230 plus 71.6, okay, well, the answer to this turns out to be what? 301.6. What is the, take a moment, underline the last significant figure, okay, pause it, underline the last significant figure in both of those. All right. That is the last significant figure. There's no decimal, so that means that I'm going to go from the first significant figure, the 2, to the last significant figure, the 3. And in the other one, the 6 is the last significant figure. What place are both of those in? The 6, the one on the right, is in the 10th place, and the 3, and from the 230, is in the tens place. That means that we are going to round to the tens place. I'm going to highlight that. So I'm going to round to that. So how do we round this? I did not expect this to happen, but that's fine. We're going to call this 300. How many sig figs is that? That's only 1. And so I'm going to change my, we would actually have to put this in scientific notation, times 10 to the second, which we haven't gotten to yet. But point still stands. We're going to round it to the place. Okay, so I'm going to give you another example to do besides this one. The other example I want you to do is please round, and I'll get it right this time. 561 plus 2300. So add those two together. What do you get for a total? Okay, all right, perfect. So that's adding and subtracting. We're always going to limit it to the least number of decimal places or the lowest place technically, but we always have decimals. So that's why I always say the least decimal places. Okay, so that's rule 1. The other rule, multiplication and division. For multiplication and division is actually much easier. You're just going to do the fewest significant figures. So if I look at this example here, I'm going to look at my 2 answers. So answer on the 2 numbers here. So 23.5. How many sig figs does that thing have? That one has 3 sig figs. How about the 0.025? How many sig figs? That one has 2 sig figs. Okay, so in that case, 3 sig figs and 2 sig figs. I'm going to write out, this is exactly what I would get in the calculator. So 0.5875. My units, meters times meters, is meters squared. And now where do I round it? Well, I've got 3 sig figs and 2 sig figs. Where do I round? My answer is going to be to the second sig fig. Second sig fig because the 0.025 has 2 sig figs, and my answer therefore should have 2 sig figs. Why? Because I'm multiplying. Multiplying equals the fewest number of sig figs. So I'm going to underline that 8.5. That 8 rounds up to 0.59 meters squared. There's my final answer. There's my final answer. Here's my final answer. Okay. So give those 2 examples a try as well as 16. We'll take a look at them in class. All right, moving on. What happens when you run into multiple calculations? And these are actually relatively fun. I enjoy doing these. It feels complicated, but I promise you it's not. What we're going to simply do is, first of all, we are going to follow the order of operations. Hopefully you remember this. PEMDAS. Okay. We're always going to do parentheses first. Parentheses. E is going to be exponent. Okay. Multiply and divide. add, and subtract. Okay, so we're going to do those. That's the order. Parentheses, exponent, multiply, divide, add, subtract. Okay, we're always going to pick the order of operations. We're only going to do one operation first, and I'm going to rewrite the rest of the problem. Okay, what we tend to do is we keep track of sig figs along the way. We underline where we would have rounded, and then at the very end, we are going to round. Okay, so we're going to do this problem, and please keep track. So first of all, we're going to follow the order of operations, doing one operation at a time. Every single time I do an operation, I'm going to underline where I would have rounded, but I'm going to take everything that's in my calculator. And then I'm going to do the next operation. Underline where I would have rounded. I'm going to put that in my calculator, or everything from the calculator, and on we go. Okay, at the very end, you underline where you would have rounded once you're out of operations, and then you finally round. Okay, so let's take a look. So here is my operation, or my math. What do you want to do first? Well, PEMDAS says, do I have any parentheses? I do. So that means the top is going to get rewritten. 3.12 times 1.4556 all over 1.432 minus 0.1 gives me 1.332. I am subtracting there, right? So where would I have rounded? Well, we're subtracting. This has 3 decimals. This has 1 decimal. My answer gets rounded to the second decimal, or first decimal. So I'm going to underline that 3 because of that one right there. Okay, because of the first decimal, the 1 decimal place, that's where I would have rounded. I'm keeping that. And in fact, I'm going to use that in my calculator in the future, but that's where I'm going to go. All right, what's the next operation that you want to do? Well, we're going to do the top. We're going to do the multiplication. I'm going to rewrite what's left, 1.332. There we go. And I'm going to continue to underline. I'll underline that first one because that's where we would have rounded. I want to keep track of that all along the way. Up top, I'm going to multiply 3.12 times 1.45562, and I end up with 4.54153444. Okay, so this is not what I want you to report, right? But you're going to keep everything. So now we take a look at our two numbers here. We're multiplying, so I'm interested in the number of sig figs. The 3.12 has 3 significant figures. The 1.45562 has 6 sig figs. Okay. So 6 sig figs, 3 sig figs. That means my answer, because I'm limited to, because we're multiplying, I'm interested in the limited to the number of sig figs. I need to find the third sig fig and underline it. That second 4 is going to be the third sig fig. So I'm going to underline that. Now I'm going to continue. So we have kept track along the way. Now I'm going to plug both of these numbers, the entirety of the whole thing, 4.5415344 divided by 1.332, enter on my calculator. I end up with 3.4095603, and on it goes. But that's the number that I plugged in. I plugged in those numbers. I didn't round, and that's what I have. I am dividing. So now the question is, how many significant figures? Because remember, multiplying and dividing, we're interested in the number of sig figs. This right here would have had 3 sig figs. This one would have had 2 sig figs. Okay, so again, those are the ones that are important. So my answer should be rounded to 2 sig fig. I'm going to underline my second sig fig. This answer is 3.4. Done. That is the final answer. I round at the very end. Do an operation, keep track. Do an operation, keep track. Do an operation, keep track. Anytime you have an underlined number, you want to round to, you want to essentially keep in mind that that's how many sig figs it would have, and we need to keep that in mind, okay? So with that said, we're going to walk through these in class, so give them a go, but we're going to talk about these in class. Oh, I am going to change something. I'm going to change this number to, we're not going to deal with powers. I'll tell you how powers work in class, but let's just put a number up here. I'm going to say 3.4 1461. There we go. So that's the number that we're going to use instead. We'll deal with powers and roots. They're actually very different. If the lower level classes generally don't worry about it. And in fact, upper level classes tend to not, but I will complete the story talking about roots in the next one or in class. All right. So scientific notation. So we want to be able to simplify numbers. Okay, simplifying numbers is really important. As we've already seen, we add a prefix in order to make numbers smaller or make numbers bigger. And we do that because no one wants to deal with abnormally large numbers, right? 346,800,000, on and on and on. That's just too tedious to deal with. Or something very, very small. How big is an atom? 0.00000000000000001 meters. Like, we're not going to do that, right? So we're going to use scientific notation, or we're going to use a prefix or a combination of the two. So it's broken down into 3 parts. So in the beginning, the first part here, 6.02 in this number, is going, this number is the coefficient. This is a number between 1 and 10, or 1 and less than 10, I should say. 1 and 10. Basically, you're only going to have a number in the, never have a number. You always have one number in the ones place, nothing in the tens place, and not a 0 there. So you should always have a number between 1 and less than 10. So you only have something in the ones place. Okay. Another thing about this is all of these figures are significant. So if you're converting to scientific notation and you have 3 sig figs, you would do something like this. So your number has 3 sig figs. Scientific notation, it's always easy to convert to scientific notation as long as you keep the same number of sig figs. The next up is, it's not really super important. It's just based on our number system. We have a 10 base number system, so that is going to be our base. What this just simply means is every time you put an integer in the next column, it's basically increasing it by 10 times, right? Going from 9 to 10 is increasing it by 1, by putting a 1 in that place. So this may seem strange, but the ancient Babylonians had a 40 base number system, meaning once you get to 39, once you hit 40, you'd put a 1 in the next slot and you'd start from 0 again. So it's not out of the realm of possibility to have a different base number system. All right, next up. This right here is the coefficient, or I'm sorry, not the coefficient, the power, or the exponent, or the magnitude. That's a really important word. The magnitude essentially tells you how large that number is. It tells you how many times the decimal places move, tells you how many times you multiply it by 10, by 1,000, by 100, by 100,000, yada, yada, yada. Or dividing by 10, 100, whatever. So it's the power, it's the magnitude, it's the size of that number. 6.02 is just simply 6, right? But as soon as I say 6.02 times 10 to the first, I'm basically saying 6.02 times 10, right? So it's become 60. So that's the magnitude. So life is pretty simple in terms of how we determine these things. The power is positive. The number is greater. When the exponent is positive, the number is greater than the coefficient. Really what that means is the decimal moves left. Okay, the number grows and sorry, the number goes right. There we go. Right, because the number is going to grow. So the 6 would go to the right, 6 to 660 to 602 to 6,020, so on and so forth. If it's negative, the number is less than the coefficient. Okay, which means you move it to the left. So let's take a look at these. So I have 93 million miles. We are, let me put a unit in, of course. So the Earth is 93 million miles from the sun. Okay, so convert to scientific notation. So right now, how many highlight or underline the significant figures? So the 9 is the first significant figure, and the 3 is the last significant figures, because all those zeros, there's no decimal. Because there's no decimal, we have to find the first and the last, and there we go. So this thing has 2 sig figs. Okay, so when my answer comes around, I can only have 2 sig figs. So let's put a decimal in now that we know the number of sig figs. There's the decimal. Okay, so I'm going to move this decimal. 1, 2. Oh, I'm going to keep moving the decimal until I get only I get some digit in the ones place. So if I move it 1, 2, 3, 4, 5, 6, 7. So it's going to stop here. I moved it 7 times, and now I have the 9 in the ones place, right? If I moved it one more time, it would be 0.9. So there would be a 0 in the one place, too far. If I stopped at the behind the 3, I would have a 3 in the ones place, yes, but I would also have a 9 in the tens place. So we always move until we get any digit, the last digit. Basically, you always move it until you will have just one digit left. All right. So my coefficient, 9.3, because I moved the decimal. There we go, times 10. And do you remember how many times I moved it? I moved it 7 times. It is a positive integer or a positive power or magnitude, because the 9.3 times 10 to the 7, the 9.3 is bigger than the 93 million, right? So 93 million is a bigger number than the coefficient, so that's a positive value. So we're shrinking the number, but we're growing it because we have that power miles. All right, same thing here. The length of a carbon hydrogen, you would never ever report this because that's just tedious to look at. So same thing, I'm just simply going to say, well, let's take a look. Let's see here. All right, so I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to stop here because I have a 1, I have a digit in the ones place. So my coefficient, I forgot how many times I moved it. Oh no, I remember now. 1.09. All of those these are all significant. All those zeros are considered placeholding zeros, so we can ignore them. So I have 3 sig figs in my number, and I have 3 sig figs in my scientific notation, times 10 to the, it's negative because the number is smaller than the coefficient, right? And this is going to be negative 10 meters. So there we go. We have our answer for the length of the CH bond in scientific notation. Good? All right. How about converting back in the other direction? So the width of the HIV virus is 9.0 times 10 to the negative 7th meters. Okay, so a couple of things. My final answer should have 2 sig figs. Okay, I'm going to start with this number 9.0, and I'm going to move it 7 times. The question is, do I need the number to shrink or to grow? Well, because this is a negative exponent, right? The answer, the digit answer, the non-scientific notation should be smaller than coefficient. So which way do you want to move it? Let's move it to the left, right? I'm going to move the decimal this way. 1, 2, 3, 4, 5, 6, 7. So I'm going to put the decimal here. I'm going to replace that with each little hump here represents a 0. Let me double check. 1, 2, 3, 4, 5, 6, 7. Good. So there's my answer. Point. 6 zeros. 1, 2, 3, 4, 5, 6, 9. And do I need that 0 there? Well, right now I have 1 sig fig. I'm going to put that 0 there. Meters, 2 sig figs. There's my answer. And you can see why scientific notation is nice, because that's obnoxious to write that 0.6 zeros and then 9 0, right? All right, perfect. So that's it for PEMDAS and calculations, but moving on to dimensional analysis after this.